Okay, so today what we're going to talk about is functions. Now, since we've already talked about this in class, I'm not going to do all the examples. I'm just going to do a couple of them just to explain the ideas, and then we'll go from there. When you're talking about functions, you see a function notation. Technically, this f of x, and then that's how you pronounce it, f of x, is replacing a y. But in this case, we're just going to look at this f of x, okay, equals this. And when we go down to the first problem, it says f of 5. What you can notice between this one and this one is the difference is one has an x and one has a 5. So by that conclusion, we had to think of it like this. This is going to be used to plug in for x. Since this is x, we're going to take all of these x's and replace them with 5. So we're going to do this. F of 5. Okay, now f of 5 equals, okay, it's going to be 5 squared plus 4 times 5 minus 5. Okay, so notice how all I did was replace all the x's with 5's. We just took this, replaced them all with 5's, and now we just solve till the end. You don't do anything to this left side. This is just essentially trying to tell you this is what we're finding, and this is the actual side we're solving. So we put f of 5 equals, now this is 5 squared. Okay, so once again, if you have a variable, in this case we don't have a variable, we do PEMDAS backwards. But in this case, since we don't have a variable, we're going to do PEMDAS forward. So first we look at parentheses. Now I put these parentheses here, but we can't do anything with them, meaning they just have a 5 in them. So parentheses are done. Then we go to exponents. Well, 5 squared. What that means is we take 5 times itself, so it'll be 25, plus 4 times 5 minus 5. Okay, so we've gotten rid of the p, we've done the p, we've done the e. Now let's do the m. Here's multiplication, so that means we're going to take 4 times 5. So it's going to be 25 plus 4 times 5, which is 20 minus 5. Okay, we don't have any division. Let's do the adding. So the adding will be 25 plus 20, which will be 45, minus 5. And then finally subtraction, we get 40. So that means f of 5 equals 40. And that's just the answer. All we did was simplify. Now on this next one, it has a negative sign. Now let me show you what happens when we have squareds and negatives. Okay, so we're going to do f of negative 2. So now we're going back up to this original equation, okay, and we're going to plug in negative 2. So that equals negative 2 squared plus 4 times negative 2 minus 5. We're going to do the same steps that we did above. Okay, parentheses, remember, we don't have anything we can really do in them, so we go to exponents. So, negative 2 squared. A lot of you guys are going to think, okay, well, this is going to be negative 4. Well, that's not the case, because we're taking negative 2 and multiplying it by itself. And when you take two negatives and you multiply them by themselves, that will be 4. It'll be positive, because a negative times a negative is a positive. Plus 4 times negative 2 minus 5. The next step, multiplication. We have multiplication right here. So it's going to be 4 plus negative 8 minus 5. Now then we go to addition. 4 plus negative 8 is negative 4 minus 5. And finally, negative 4 minus 5 is negative 9. Okay? So, it doesn't always have to be f of x, but on one of your worksheets, you're going to see something like this. You're going to see f's and you're going to see g's. So if you see an f, that means you're using the one that has an f. If you see a g, you're using the one that has a g. Okay, that's the only difference. Is it's just telling you which function to use by the letter that's in front. That's how you solve those things. Now, onto domain and range. Okay. Domain is all the possible x values in an equation. Range is all the possible y values in an equation. So when you first look at these are just points. These don't have to deal with the graphs down below, but these are just points. First letter is always the x, next one's the y. It always goes x, y, all the way through. Okay, because x, y all the way through. So we first want to find our domain. Domain means all the x values. So first I'm just going to list out all the x values I have. So I have a 3, a 5, a 7, a 3, and a negative 2. So that's what I'm going to write down. 3, 5, 7, 3, negative 2. But not only is it all the possible x values, it's all the possible x values in order without repeating. So we're going to now spruce this up a little bit. So first, the smallest number is negative 2, so we're going to write that down. We're going to write negative 2. Next is 3. But you'll notice we have 1, 2 3s. Okay, so we have 1 and 2 3s. So we had to cross out 1 just to say, okay, so we're only writing 1 down, so I'm going to write 1, 3. Then it goes 5. Then it goes 7. So then we're going to do the same thing for the range. Write down all the numbers we got. We have a 5, a 4, a 2, a 7, and a 3. 5, 4, 2, 7, 3. From there, all we're trying to do is put this in order from least to greatest. So the smallest, 2. So we're going to do 2, then we're going to do 3, then we're going to do 4, 5, and then 7. So this is your actual range, and this is your actual domain. Okay? So all you're trying to do is write the x and the y values. That's a little bit easier than finding it on a graph. Now when you're looking at a graph, you have to notice something. These little lines up here, they mean they're going up forever. So always, for the most part, think of the graph as it's going up and down wherever the ends are. So the ends are showing you going up both ways. So this is what I tell everyone to do. Your domain is your x values, which means this is the left and right stuff. So if you're going from left to right. So if we're going from left to right, that means I'm going to start with left, and I'm going to go to right. Okay. So there's two possibilities. One is it going left forever, or is it not going left forever? If it is going left forever, that means we're going to have an infinity. If it's not going left forever, it must end somewhere, and we write the number down where it ends. Now, this is going to be a little confusing, but I want you to think it like this. Okay, so you're going up. So this is the x values, is just telling you all of these over here. So right here, you're going up and slightly to the left. Now, it is technically still going to the left, even though it's slightly going to the left, and it's going to the left forever because this extends out forever. So it's going to go up and to the left forever. So does the left go on forever? So you say yes, it does. And how? Okay, and then what do we call that? We call that negative infinity because it's going to the negative x's. Since it's going to the negative x's, it's negative infinity. The next question: is it going right forever? The answer once again is yes. It's going up and to the right. So yes again, but it's going infinity. Okay, that's the domain. So the domain is a parenthesis, infinity. Negative infinity to infinity, which actually means that any x value is incorporated in this function. The range. The range, once again, is the y values. The y values are up and down. Okay, so they're going to be, I'm going to first put down, and then I'm going to put up. Okay, so down and up. Question: is it going down forever? Well, these arrows are pointing up. There's no arrows pointing down. So that means no. Well, if it's no, where does it stop? Well, we gotta look. What's the lowest point of the y-axis this goes to? And if you can see right here, it only goes to the 0. Now, the question, is it going up forever? Well, yes. In both directions, it's going up forever. So it's infinity. So my range is from 0 to infinity. Now, it's okay if you don't remember this, the brackets and stuff,
but I want to show it to you like this. If it's a number that's not infinity, we're going to put this little bracket sign here. Okay? But if it's infinity, you put the little parenthesis. I'm just going to briefly explain this one just so we can see. Okay, so you can notice a bunch of things. One, it's going down and to the left forever, and it's going up and to the left forever. So that's why on your worksheet it shows negative infinity to positive infinity for both the range and for the domain, because it's going up and right, down and left. So we've covered all our bases, and that's why in your worksheet it says both. Something that's a little bit harder though is like a circle. So on your worksheet, you'll notice the question is this going up, left, right, down forever? Okay, so the answer should be no for all of these, because if you notice, it always ends. So if I was going from left to right, this is my domain, I'd first look at how far left do I go. Well, I go to -6 on the left. So right here's -6 on the x-axis. That's how far it goes over. And right, it goes to the +6. Range, same idea. How far down does it go? Well, it doesn't go down forever. It ends at -6. So we write -6. Up goes to 6. Okay, that's the idea of domain and range. Now, is something a function? I find it hard to really explain what this is if I connect this to real life. So let me give you a little biology background. Females have XX chromosomes, meaning how it tells you whether, like, how your sex is determined is whether or not you have an XX chromosome, or if you're male, you'll have an XY chromosome. Okay? Now, I'm more worried about what's the differences between us. We all have one X. Well, what's the difference is one has a second X, has a Y. So we're going to pretend X values, or domain equals females. Range equals males. Okay? Now, in society, let's think about this. I know this is incorrect to really think about, but in society, what we say is if a female has more than one boyfriend, we think of her as a derogatory term. Okay? Males, we think, oh, they're players, they're great. The fact is that they are allowed to do it, and females are not allowed to do it. Now, I know this is a double standard, but for math, we're just going to talk about it right here. Okay? So, when we're talking about functions, when I say a function, I mean that every domain, or every female, has one and only one boyfriend. Functions have only one boyfriend. As long as that is true, it's a function. Now, when the females start having more than one function, or more than one boyfriend, that's when it's not a function anymore. Okay? We don't care about the males. In society, no one cares about the males. They only care about the females. So when we're paying attention to whether or not the function, we don't care about the males. We only care about the female, meaning the domain. So let me show you what that means. I'm going to show you two different things. First one being this one right here. So first, let's find the domain. It is, okay, so our numbers. So I'm going to write 4, 3, 2, 8, 7.
So that's our domain. Range is 5, 4, 5, 2, 9. Okay, in the range, the 5s repeat, so we're going to cross out one of the 5s. We don't care about that. And then we're going to actually make 2 little boxes. One for the domain, one for the range. Okay. In the first box, we're going to put the domain from least to greatest. So I'm going to start with 2, 3, 4, 7, 8. Okay. And in the right hand box, we're going to put these from least to greatest: 2, 4, 5, 9. Now, once you've done that, what you're going to do is we're going to go back up to these little points. And we're going to draw lines from the x's to the y's. So the first one, 4, we're going to draw to 5. So we're going to look for 4, look for 5, and we're going to draw from 4 to 5. Then we're going to do the same with the 3, 3 to 4. Then we're going to do 2 to 5, 8 to 2, and then 7 to 9. Okay. Once again, we only care about the females or the domain. Do any of these have more than one line coming off of them? The answer should be no. Even though this 5 has more than one line coming off of it, that's the range. It's the males. We don't care about the males. We only care about this side, the females. So do any of these have more than one line coming off of them? The answer is no. So it is a function. All the females only have one boyfriend. Okay. Now this one over here. Same idea. Okay. But I'm going to shortcut. I'm just going to do straight go to the boxes. Okay. Domain, range. Alright. So we have 3, 7, 3, 4, 1. So it's going to go 1, 3, 4, 7 because the 3's repeat. The range. Okay. That's 3, 4, negative 5, 9, 2. So we're going to go negative 5, 2, 3, 4, 9. Okay. The next step is to connect our stuff. So we're going to go from 3 to 3. So we're going to draw a line from 3 to 3. Then it'll be 7 to 4. It'll be 3 to negative 5. It'll be 4 to 9. It'll be 1 to 2. Okay, now we can look at this. Do any of these females have more than one boyfriend? Yes, the 3. Okay, so society says that's bad. And we're going to say that's bad just in terms of math. So this means not a function. Okay. So we only care about the domain. If we have a number that has more than one boyfriend, then it's not a function. Finally, vertical line test. Okay. Vertical line test is the way of telling if something's a function when you're looking at a graph. Vertical line means an up and down line, so an up and down line. Okay. What we're only looking at is the u, this stuff. Okay, we're only looking at the graph itself, and we're asking ourselves, anywhere on that graph, can I draw a straight line and it goes through the graph more than once? If the answer is no, then it's a function. If it's yes, then it's not a function. Let me show you. Like for this u, I cannot find a single spot on this u where I could draw a straight line up and down and goes through more than once. If I drew a straight line right here, or a vertical line up and down, it only goes through the spot once. One right here, same thing. There's nowhere I'm going to be able to find where I can draw a vertical line and it goes through more than once. So this is a function. However, on the one next to it, I can choose many spots. If I draw a vertical line right there, it goes through not only once, but twice. So this would be not a function.
Then you've got your straight line. This is a function because there's, once again, not a spot. And what about the circle? Well, once again, I could draw one right there. It goes through once, twice, so not a function. That's how you can tell whether something is a function or not. Try the worksheets out and bring them in if you need to. Thank you.